Now we'll finish this section with a subject based on numbers and letters, mathematics. Here we'll learn about complete factorization, the grouping method, rational algebraic fractions, multiplication, division, addition, and subtraction of algebraic expressions. Complete factorization involves factoring at the last part of an algebraic expression. To perform complete factorization, we must first check whether we can find a common factor, and if so, factor it. We also need to review what type of expression we have. If we have two terms, we determine whether it's a difference of squares or a difference of cubes, and if so, factor it. If it's a trinomial, we check whether it's a perfect square trinomial or the form ax squared plus bx plus c. But if it's a four-term polynomial, we use the grouping method to factor it. With all of this in mind, the only thing we have to check is what type of terms we're trying to factor, and depending on this, we use the respective method. Now, since we're talking about the grouping method, I think it would be good to go into more detail about it. The grouping method is mostly used when we're working with polynomials with more than three terms. And let's say if we have a four-term polynomial, what we do is break it down to two terms and check if it has a common factor, or if it's a difference of squares. If, when we take the common factor, the parentheses are the same, what we do is put the outer terms in another parenthesis, and that's how it would be factored. Unless you can do something else in the parentheses, in that case, factor as much as you can, and that's how it would be solved. The next topic we covered was rational algebraic fractions. In this section, we'll learn how to simplify fractions with algebraic expression and certain rules you must follow to solve them correctly. The first thing they taught us was that the denominator 0 does not exist in a fraction. So, if we have to replace a variable in the denominator, we cannot use a number that makes it 0. For example, if the denominator says x minus 6, x cannot be 6, because otherwise the denominator will be 0, and that cannot happen. The other thing they taught us was how to simplify fractions. In monomials, it's quite easy, since the only thing we have to do is look for a common divisible between the coefficients and look at the same variables, and subtract the exponents. For example, if we have to simplify ax squared g5 divided between 4x4 g3, this would be 2g2 divided into x squared. This is because when we have the exponents of the variables, where the largest is where the result is located. When we have binomials, things change. The first thing we have to look, as always, if there's a common factor. If there is, we factor. We also check if there is any difference of squares or cubes, and if there is, we factor it.